This is another gate problem on multiple diodes, and this is in continuation with what we had covered in one of our previous lectures on multiple diodes. So the problem statement is that assume that the diodes are ideal in the figure shown below. The current in diode D1 is option A 8 milliampere, option B 5 milliampere, option C 0 milliampere, and option D is negative 3 milliampere. And this is the direction of flow of current through the diode. Now, one of the solutions that we can eliminate straight away is that the option D, which is talking about negative current flow through the diode, that means instead of the current flowing from anode to cathode, negative 3 means that the diode of 3 milliampere magnitude will flow from cathode to anode. Now, obviously, this is an impossible situation because diodes do not allow conduction of current. Ideal diodes will not allow conduction of current from cathode to anode. It will only allow the current to flow through the diode from the anode side to the cathode side. So option D is straight away eliminated. Now let's proceed with the template that we followed the last time around, and we said that when in confusion, what we should do is we should assume that both the diodes are on, and by on I mean that the diodes, if ideal, should be replaced by a short circuit, and if the diode is off, then it implies that an ideal diode should be substituted by an open circuit. So because we are assuming that both the diodes are on, therefore this was the diode D1, we have replaced it with a short circuit, and then this is the other diode D2, so we have also replaced it with another short circuit, and the rest of the circuit remains the same. Now the next target is to find out the direction of flow of current through these diodes, and therefore we can see that this node will be at 0 volt because this is a direct short to ground, and we can evaluate the value of this current I, which occurs due to this 5 volt source, and we can write this current I as 5 volt minus of 0 volt by 1 kilo ohm. So current I is equal to 5 milliampere. This is the direction of flow of current I. Over on this side, we find that here is 0 volt and here is negative 8 volt. So the difference is of 8 volts here, and the resistance is of 1 kilo ohm. Therefore, the current I2 will be equal to 8 milliampere. So this was a current which was of value 5 milliampere. The outgoing current is 8 milliampere, and therefore it is expected that the 3 milliampere current, in order to satisfy KCL, should flow from this node up, and this implies that the diode is now conducting from cathode to anode, and this is the impossible situation. So this simply means that this diode is actually off, and because this is off, then you can substitute this diode by an open circuit, and the current I1 in that case will be equal to 0 milliampere. Therefore only diode D2 will be in existence, and we can find out the current through this diode D2. So current through the diode D2 will be 5 minus of minus 8 divided by 1 kilo ohm plus 1 kilo ohm, which is equal to 6.5 milliampere. So diode D2 is conducting a current of 6.5 milliampere, whereas diode D1, because this is an open circuit, it will not conduct any current, and therefore the current through diode D1 is equal to 0 milliampere. So option C is the correct answer for this particular problem. Note that in the previous lecture where we had discussed about multiple diodes, luckily we had found that both the diodes were on, and therefore we could solve the circuit as it is. Whereas in this case, although our initial assumption failed because diode D1, we had assumed that diode D1 is also forward biased, or in other words, this is also on, as also diode D2 is on. It turns out that diode D1 is actually off, whereas only diode D2 will be in forward bias condition, or it can be represented by a short circuit, whereas diode D1 should be substituted by an open circuit, and we should again resolve the circuit.